Hello, my peeps, and welcome to another Power-Packed Phillips podcast. I do believe there has been an EOC score sighting for Week 9. Drum roll, please. The top 10. Dun 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 dun. I know C, Veterans Park. So let's keep going. 11 through 20. No Veterans Park. 20 through 25. No Veterans Park. Aw, man, supercalifractions, you missed a check mark by 0.2 minus 0.1, 1/10. Are you kidding me? And Math Munchers, you missed a check mark by 0.2, 2/10.
What?
Unbelievable. Well, kudos to you for 26th and 27th, but no check mark for you. Here is the rest of the top 50. Fraction freeloaders, 38. What can I say?
Loser.
Could it be another EOC sighting? Maybe, possibly. Can I keep procrastinating until I find my sound effect?
Oh yeah.
Here we go, Week 10. We need a drum roll. The top 10 for Week 10. No Veterans Park. The top 20. Hey! Oh, wait. Thundering third. That would be Mr. McGrath's class.
Loser.
No check mark. So far. Yay! Math Munchers! Let's get a cool sound effect for you, Math Munchers.
Hey.
Oh no, we can do better than that. I think. Maybe. Possibly. Alright, Math Munchers, I owe a check mark to you. Nice job. And that rounds up the top 25. Fraction freeloaders, you were 31. Supercalifractions, you were 32. No check mark for you.
Loser.
Gotta work harder next time. The rest of your MSAs, please read. Alrighty, please write in your notes. This would be lesson 7.5. Bada bing, bada boom. Special types of linear systems. Lesson 7.5, special types of linear systems. We've been working with systems of linear equations that have one solution or one accident. Nice pick, thanks. So for example, if we graphed these two linear equations, we would say the solution is the ordered pair 3, comma 2. Oh, we haven't had our sound effect for the EMC services yet. We haven't had that in a while. Here we go. So you would tell the paramedics, firefighters, to go right 3 and up 2. One solution, one accident. Now we are going to look at special systems. So for today's podcast, let's take a look at a special system where there is no solution. Special system where there is no solution. Here we go.
911, what's your emergency?
Our emergency is we have to prove that this linear system has no solution. So here we go. Please write down this system of linear equations on your paper. We are going to try to eliminate either the variable x or the variable y. I'm choosing to change the x's to a plus 3x and a minus 3x. So I need to change one of the x's. You didn't see that, boo-boo. I told you didn't see it. We need to change one of the three x's to a negative 3x. So here we go. I'm going to take this 3x and I want it to be negative 3x. So I'm going to ask myself, 3x times what number would give us negative 3? Well, I know that 3 times negative 1, 3 times negative 1 gives me negative 3. So I'm going to multiply every term in the equation by negative 1. So this gets multiplied by negative 1, this gets multiplied by negative 1, and this gets multiplied by negative 1. So I do 3x times negative 1, and 3 times negative 1 gives me negative 3, and my dog, X, follows me everywhere I go. I think we have a dog around here somewhere. Give me just a second. Told you. Now I'm going to do positive 2y times negative 1. Positive 2y times negative 1 gives me negative 2y. My dog, in this case y, follows me everywhere I go. Now I'm going to do 10 positive times negative 1. 10 times negative 1 gives me negative 10. Now I'm going to stack the equations on top of each other. I'm going to stack the equations on top of each other. So now we will combine like terms. Negative 3x and positive 3x gives me 0. Negative 2y and positive 2y gives me 0. That's strange. We've never had both variables cancel before. A negative 10 and a positive 2 gives me negative 8. 0 plus 0, or 0 minus 0, whatever makes you happy, gives you 0 equals negative 8. 0 does not equal negative 8. Negative 8 equals negative 8. So we say this is a false statement. They are not the same numbers. They are not the same numbers. So this is a false statement. So please write down on your paper, a false statement equals no solution. Or a false statement is like no car accident. So anytime you have a false statement, there is no car accident, there is no solution. It's kind of like these two trucks. They're just going to keep flying down a track side by side, divided by this median, and they are never going to intersect each other. They're never going to touch each other. So there's no car accident or no solution. Yes, the harp means we're almost done. So here we go. You can listen to the harp when you're done. If we wanted to, we also could graph them instead of using elimination. Please watch. Do not write this down. If we happen to graph the same equations, notice that they make parallel lines. Ooh. Ah. Parallel lines. There is no car accident because the lines do not intersect. So now, if you would write on your paper, please, parallel lines do not intersect, so the system has no solution. Please write on your paper, parallel lines do not intersect, so the system has no solution. So let's summarize so you can enjoy your harp. Please write down summary. If you use elimination and you get a false statement, there is no solution. If you choose to use elimination and you get a false statement, we say there is no solution. If you use graphing, and you get parallel lines, we say there is no solution, because parallel lines never touch or intersect. So please make sure you have the summary down. If you use elimination and you get a false statement, we say there is no solution. If you use graphing and you get parallel lines, that means there is no solution. I told you you could listen to the harp. Later, alligator. In a while, crocodile. Just hit the stop button, my God.